Welcome to Mrs. Mahoney's podcast. This is our fourth and final one in our Unit 8, stoichiometry. And we're just going to be looking at stoichiometry and realizing we have one other way we can look at it. Nothing new. It's just going to be one new conversion that we can use. So this is the additional page to your packet that I had you pick up today. So let's look at if they give me some energy. Now these are called, you may want to kind of write these down. This is also called a thermochemical equation. Thermo meaning energy, chemical meaning what we've been looking at. It's a chemical reaction. So if you see something included with an energy, look at this right here. I'm looking down this example and see how energy is involved. That is a thermochemical reaction, or equation. So let's look at what it's telling me then. If energy is a product, meaning, again, okay, hopefully you can realize how many times this has shown up. I expect that you know what the equation side of the equations. What do we have? I have reactants becoming products. It's all about which side of the arrow it is on. And I can't finish writing that. You can finish writing it though. So if energy is on the right side of the arrow, that's what it means. We say it's exothermic. That means that energy is being released. These are the ones that get hot. Well, then if the energy is a reactant, or what does that mean? On the left side of the arrow, we say the reaction is endothermic. So that means you need to pay attention because this changes the sign of the energy. So let's look at this reaction. Okay, where is this product? Where is the energy? The energy is a product, therefore it's exothermic. What happens, what's the difference? When I write it, what is the energy involved? I'll put a negative in front of it because it's exothermic. Exothermic gets the negative because it's being released. This is exothermic. Well, with this, let's look what this says. It says, for every 1 mole of glucose, I need 6 moles of oxygen, and I produce 6 moles of carbon dioxide, and I produce 6 moles of oxygen. I also am releasing 2,560 kilojoules of energy. So for every 1 mole, that's how much energy. For every 6 moles of oxygen, this much energy. 6 moles of carbon dioxide, this much. Look at, that's another ratio that we can use. And again, it has to be in moles because that's what our balanced equation is. So let's look at this, how an equation could look. How much heat is released when 1 mole of glucose? Well, for every 1 mole of glucose, C6H12O6, let's look at our balanced equation. Same thing's going to set up, but this time instead of wanting grams or instead of wanting molecules, I want energy. That comes from my balanced equation. I know that I get 25,600 for every, let's look at my balanced equation, 1 mole. Okay, now as far as sig fig, since these are just using exact numbers, exactly 1 mole from the balanced equation, I'm going to go ahead and write all of them because it's exactly the 1 mole, 25,600 kilojoules. Okay, I'm not 100% right. So what does that mean? I need to put the negative. And you really, really need to be aware of that because I've seen many times, again, they give you the right number, and I know we talked about this on the last test, but the sign is going to be different. So you need to know negative means exothermic. Okay, well let's look at another example. How much heat is released when 3 moles of oxygen? Well, we're going to start just like we always start. What I know, I have 3 moles of oxygen. Then I go to my balanced equation to see this relationship. So it's the same amount of energy, 2,560 kilojoules, for every 6 moles of oxygen. So if you look at, I have half the amount. Well, it should make sense then. I'm going to get out half the energy. Don't trust me? Look at your put on the calculator. 3 times 2,560 divided by 6, and you'll get 1,280 kilojoules. Again, negative because it's exothermic. Okay, what if I reverse reaction? Well, let's just write it. If it's reverse, what happens? Everything switches. If it was a reactant, it becomes a product. So I have that much, 6 moles of carbon dioxide are going to react with 6 moles of water. Now this time you're going to have to add 560 kilojoules. And if I do all that, what do I get out? 1 mole of glucose and 6 moles of oxygen. Hopefully these look familiar. Photosynthesis, you guys have all seen these. Thought I used a reaction that was similar or something that should have been familiar. So what happened to my energy? Well, look at what it is now. It's a positive 2,560 kilojoules. And that means it's became endothermic. And how do I know that? It's a positive. I also know it because my energy is a reactant. It's on the left side of the arrow. So how much energy would I need then to make 12 moles of glucose? Well, let's see. If I wanted 12 moles of glucose, and again, for right now, I'm not really paying attention to the significant figures. When we get down here and start looking at the grams and get a little bit more specific, then I will. What do I know? Look at my balanced equation. Well, for every 1 mole of glucose, I need 2,560 kilojoules. So for every 1 mole, I need that much. Well, if I have 12 moles, then I'm multiplying. So how much energy would I need? 30,720 kilojoules. And again, it's a positive energy because that's an endothermic. That's how much energy I need. Well, let's look on down. Couple this. Let's just purely, you want to tell me, is this an exothermic or endothermic? Let's practice on the sign. So look at this. Delta H, that means the heat. What is that? It's right here. So what would it be? I'm waiting for you all to write down. Okay. Negative 393.5 kilojoules, because you know we always label our numbers. Type, endo or exo. This is exothermic. Okay, let's look at this other one. So I have calcium carbonate, and it's going to decompose. Well, most decompositions need some energy. So how much does it need? It needs a positive 176 kilojoules. That means this one was endothermic. The sign matters. You really, really have to pay attention to it. Okay, I want you to do 2 and 3. This time they're going to be a little bit more work. Little more work. It's one step. Look at the difference. Because what did I give you? I gave you grams instead of water. So if I give you a gram, what do you have to do? Yep, convert grams to moles. Then you can do this step. So I just wanted to show you the new step. Grams to moles, you know how to do. So 2 and 3 you are doing on your own, and then that's where we're going to start tomorrow. And then tomorrow we're also going to do a lot of review to get you ready for that test on Wednesday. See you tomorrow.